students. We're going to work on Chapter 5, Section 2. We're really going to pinpoint two basic theorems. In this video, we're going to talk about the Circumcenter Theorem. Circumcenter Theorem. And I just wanted to kind of point out a couple of things to you up here. This is what it says. When three or more lines intersect at one point, the lines are said to be concurrent. The point of concurrency is the point where they intersect. You saw that the three perpendicular bisectors of a triangle are concurrent. That was in a picture. If you have your textbook, that'll be above at the top of your page. This point of concurrency is the circumcenter of the triangle, which is what they've drawn for you right here. So this is going to be an electronic notebook edition, the Circumcenter Theorem. And I'll try and find this figure for you. So I'll cut that out somewhere, find it online, and get that to you, probably using Google Slides. But this is what the theorem says. The circumcenter of a triangle is equidistant from the vertices. Okay, I want it underlined, equidistant and vertices. Because when we do our second theorem, it's going to sound similar and it's going to be real easy to get confused. Okay? So circumcenter, it is a point. It could be inside the triangle, and in this case, it could also be outside, as you can see down here. The circumcenter can actually be inside, outside, or even on the triangle itself. So for acute triangles, we're expecting to see the circumcenter on the inside. If it's an obtuse triangle, the circumcenter is going to be on the outside. And for right triangles, it's actually going to be on a side. And that's what you see from the figures there. The circumcenter, here's another really neat point. The circumcenter of triangle ABC is the center of its circumscribed circle. Okay, circumscribed. When you think of the prefix circum, or this root word circum, you know, like we've done circumference. Do you remember we've done that before? You guys know that word very, I can't spell it, but there we go, circumference. We know that we're measuring the outside of a circle, right? That's kind of like a perimeter of a polygon is circumference of a circle. Basically, those are the same things. We just use two different words for that. And what's happening is when you do a circumscribed circle, you are the center, that circumcenter is the center of the circle, and it literally, the points, each of the vertices of your triangle lie on your circumscribed circle. Okay? So circumscribed circles go around the triangle. Okay? They're going to go outside of the triangle and kind of enclose the triangle. So think of circumscribed means enclose, enclosing of the circle, or encloses the circle. Okay? And so what I wanted to remember about the Circumcenter Theorem is a couple of things. There's a lot of stuff on this paper, on this page here right now for notes. The biggest thing I want you to remember is that wherever that point is, it is equidistant from the vertices, So that means PA is the same length as PB is the same length as PC. That's the most important part right here. Okay? So that's what's going to happen is we're going to end up being able to solve some math problems with this knowledge about circumcenters. So circumcenters, they are equidistant from the vertices. Okay, so that's important. They're equidistant from the vertices. So that means PA, PB, PC, they're all equal in length. You can find a circumcenter inside the triangle, outside the triangle, on the triangle itself. And then you will be able to circumscribe a circle and enclose that triangle, enclose the triangle with a circle and have the vertices of each of your triangle on the circle itself. And then that circumcenter is actually the center of your circle. Okay, so let's take a look at example 1 now. We're going to use properties of perpendicular bisectors. We're going to talk about them, figure out what's going on here. Okay, it says KZ, LZ, MZ. All three of them are the perpendicular bisectors. So I'm just going to draw some little marks here. Okay, I'm going to put a little box here so that you know that. Okay, now let me go back a page and point this out to you. The perpendicular bisectors, if you look here, do you see that one right there? There's a perpendicular bisector, there's one, and they all meet and form the circumcenter of the triangle. So if you're hearing the words, let me flip the page back, perpendicular bisectors, and you see them meeting inside the triangle or outside the triangle if it's an obtuse triangle, or on the triangle itself if it's a right triangle, then you have what you have here in this particular case, right here where point Z is, that's your circumcenter right there. And so that theorem comes into play. They want us to find the measure of HZ. So I'll kind of darken that right here. They want you to figure out how long HZ is. And you should be able to use the figure to determine that. There should be enough information for you to figure this out, okay? So HZ, what we know is the meeting place of the perpendicular bisectors is at point Z. So what that should tell you is that GZ, HZ, and JZ are all equal to each other. That's what the Circumcenter Theorem states, that should happen as a result of these perpendicular bisectors forming the circumcenter. And so if you know one of those values, then you know them all. And we know one of them. We can see from the figure that GZ is 19.9. So if GZ is 19.9, then HZ is 19.9 as well. Did everybody see that? I hope you did. And if you're not sure that you saw that really well, bring that to class tomorrow so we can talk about it. I certainly want to be very, very clear with you. Okay, now I'm going to go down into the check it out. We're still going to use the same diagram. And let's look for GM. GM. Now remember, a perpendicular bisector, it's not only going to be perpendicular to the segment, it's also going to bisect it and split it into 2 equal pieces. So, hey, we know that they're perpendicular bisectors, so if you know what MJ is, then you know what GM is, because ZM bisects GJ. So GM has to also be 14.5. Okay, do you see how you can use the figure to determine, there is enough information here to make these determinations. So I'm going to leave 1B and 1C for you. That'll be 1 point each if you can determine the length based on our figure there. What is GK, the length of GK, and then what is the length of JZ. Okay, now let's go down to example 2. We're going to find the circumcenter of a triangle. Now, they've given us some information. One thing I do need to correct is that, I don't know why, this is the second time I've seen this, they don't mark that as a -4, and I don't know why, but that's a -4 there. So if you'll put a negative sign, we're on the negative side of the axis. Origin is right here, okay? There's the origin where my pencil tip is. And if you're to the left of the origin, you're in negative land, and that should be a -4, not a +4. What they've done is they've graphed each of these points. So there's -6, 0 there, here's 0, 4 here, and here's 0, 0 here. And that does form a right triangle. And I hope you can see that. There's no mistaking that this is a right triangle. So the first thing they ask you to do is graph the triangle. It's there for you. It's a right triangle. Hopefully you can see that, okay? Because you have one side that's on the x-axis, the other side's on the y-axis. That's automatically perpendicular to each other. So this is a right triangle. Now step 2, we got to find the equations for the perpendicular bisectors. This is actually really simple. Okay, let's start with the y-axis right along here, okay, from the origin on up to point S, okay? So O to S. You can count how many units that is. That's 1, 2, 3, 4. That's 4 units. It is 4 units long. To split 4 units in half, then the perpendicular bisector would be this line that's cutting straight through it like this. And we want the perpendicular bisector, and we want it to break up OS into 2 equal pieces. And we did. So we're running right here. That's going to end up, all horizontal lines are y equals, and then you just got to figure out, well, what number is it going through on the y? And it's going through +2. Okay? So that's the perpendicular bisector of OS. Okay? Now, the perpendicular bisector for RO, okay, you got to figure out how long it is. So we've got 1, 2, 3, 4, 5, or I'm sorry, 1, 2, 3, 4, 5, 6. So it is 6 units long, okay? That's how long RO is. And so half of 6 would be 3. So we want to count in 1, 2, 3. And this is the line that's the perpendicular. It bisects RO, and it's also perpendicular to RO, okay? And because that's a vertical line, we always do vertical lines as x equals. And so x equals -3. That's actually where it's running through, is through the -3 on the x-axis. Okay? So those are the equations for the 2 perpendicular bisectors, and I actually used the graph to help me figure it out. One's the vertical line, one's the horizontal line. Okay? And then you just look for the intersection of the 2 equations, because we're looking for the circumcenter. The circumcenter is the point of intersection of your 3 perpendicular bisectors. Now, we're not going to find the perpendicular bisector of RS. It's really unnecessary to do that 3rd one when we can clearly get it and figure it out from the other 2. You don't necessarily need to do all 3. You can do all 3, but you don't necessarily need to. So to find the intersection, you can either look at your graph and go, okay, what's the name of that point right there? Or you can look at it and go, okay, I'm going to use my 2 equations. -3 is the x, +2 is the y. So here's your circumcenter right there. That's the intersection. That's the point of intersection. Okay? And that is at the circumcenter of this right triangle. And we know that for right triangles, the circumcenter is actually going to be on the hypotenuse in this particular case. That's what's true about right triangles. Okay? Well, that's all I've got for you. We're just kind of put examples 1 and 2 together, and I figured that would probably be a good idea since we're basically talking about the same thing, the circumcenter. Okay? Write down any questions you have, and we'll talk about it in class tomorrow. Thank you very much.